Okay, all are quiet, so I assume got no questions. Okay, let us start today's lesson. Okay, so we have learned Tn, okay, for geometry progression. So today we're going to learn Sn, okay, for geometry progressions. Okay, first of all, you have to know how to get the formula. Okay, before that, I want to show you whether this formula will be given during exam or not. Also not very sure. Old syllabus, yes. Okay, new syllabus. Let's see this. Given okay, this is for AP, this is for GP, this is for AP, this is for GP. But the S infinity is not given, which afterwards we were going to learn it lah. That one is not given. This 4 is given only. Okay, Okay, I come back to the textbook. Okay, even though this is given, okay, this formula is given, but sometimes the question may ask this way, derive the formula for Sn of geometry progressions. So you have to know the step how to get this. Okay, so you see, okay, very simple. You just start with this. Consider a geometry progression with the following terms. Okay, so the first term is the A, second term as the AR, third term as the AR squared, then fourth term as AR cubed, and then continue until the last term is ARM minus 1, which is this one actually is the formula for Tn, okay. Okay, let's say the sum of the first n term is Sn, means you add out from the A until the last term ARM minus 1. Okay, you write out. Okay, Sn equals to A plus AR until the last term ARM minus 1. Okay, this one is the first equation. You set as a first equation. After that, you see here, why they times R is because after it times R, this AR squared, all these terms can be cancelled. Okay, so this is the purpose they want to times R to these first equations to get the second equations. Okay, so first equation times R, left hand side times R, right hand side every terms times R. So this is what you get. Okay, next you just minus out. Okay, so that all these term will be cancelled off. All these term will be cancelled off. Okay, it's either first equation you minus with second equation. If not, the second equation you minus with the first equation. So there are two formula will come out Okay, but actually these both formula are the same. Okay, so we will see how afterwards. Okay, the first one is the use of first equation minus the second equations. Okay, so this one, first equation is this. So you will end up with Sn minus Rsn on the left hand side. Okay, then on the right hand side, all this you can cancel off. Okay, cancel. Only left this and this. Okay, so it's A minus A r to power n. Okay, A minus A r to power n on the right hand side. Okay, so you see now it becomes this way. Okay, then you factor out your Sn because you want Sn. Okay, then the balance is 1 minus r, bring to the right hand side. Okay, become divide. Okay, this is how you get the formula. Okay, then for the right hand side, you can factor out the A, then this one in the bracket, you will have 1 minus r power n. Okay, next. This is the first formula if you are using first equation minus the second equation. If you are using the second equation minus the first equations, okay, we do the same thing. Then you will end up with something like this. Okay, so you have two formula. Okay, actually these two formula, when you apply it, any formula you use, actually is the same. But it's just here, they try to control it in this way. Okay, if the modulus of the R is smaller than 1, okay, what's the meaning of this? Modulus of R smaller than 1, okay, means your R is in between this. Okay, is in between -1 to 1. If a modulus R is bigger than 1 means your R is bigger than 1 or the R is smaller than -1. Okay, then you use this so that you will have a positive lah. Here we'll have a positive value. Then this one, if you have this, then you use this formula, then the denominator will have a positive value. That's all only. Okay, but remember one thing, the R we don't take 1. Okay, because 1 minus 1 at the denominator is 0. Okay, 0 will give you infinity. So the R here we don't take as 1. Okay. So this is how we derive the formula for Sn. Okay. So if you think that you cannot remember the step, then all this you need to copy lah. This one you need to copy as your notes. Okay. I just afraid no. The question may ask you to derive the formula. Okay, and then we go down. Okay, this one in your AP you also learn the same thing. Okay, so AP, GP the same thing. Okay, sometimes they straight away give you the SN formula. They don't give you the TN formula. Then they ask for TN. Then you can use this formula to help you to get the TN. Okay, TN is equal to SN minus SN minus 1. Okay, example here. Okay, T5 is equal to S5 minus S4. Okay, so never mind, I can show you one more time. S5 means what? Okay, means T1, T2, T3, T4, and then T5. Okay, S4 means T1 until T4. S4. Okay, so your S5, you minus out the S4, you minus out this one. Then your balance is, or you will get the T5. Okay, this is why we say that T5 is equal to S5 minus S4. Okay, so you can use this formula. Okay. Okay, and then another terms for you. Okay, what's the difference in progression and series? I think AP we also mentioned it. Okay, if progression in between is comma, then series in between is plus. Okay, actually it's the same thing. Okay, it just the terms. Okay. Okay, then we come to this example. Okay, let us see this. Okay, given that a geometry series, okay, because why it call it series, don't call it progression, because here they write it as plus. Okay, but the same thing. This one means the first term, then this one is the second term, and then continue. Okay, find the sum of the first 10 term. Okay, same thing you will need the A, you will need the R. Okay, so the A is 1, okay, the first term. Okay, the R, you take the second term, divide the first term. So 5 divided by 1, you get 5. Okay, then you just use a formula. Okay, which one you choose? It depends on the R. Okay, if the R is this R is bigger than 1, so you use the formula with the R minus 1 at the denominator. Okay, so that here this part the denominator will appear as a positive. But I repeat, it doesn't matter for you to use another formula. Okay, you will get the same answer. It just you have a negative. Make sure you don't make careless mistake. Okay, so you just put in the formula for S10. Okay, then you will get the answer. Okay, for the B, find the value of the N where Sn is 3,906. Okay, so 3,906, let it equal to Sn, then Sn put in the Sn formula, but now you have the A, you have the R, but you don't have the N. Okay, so first of all, 5 minus 1 is 4, bring to this side times 4. Okay, next, minus 1, bring to this side plus 1. Okay, when come to this state, okay, is either you want to try to find the 15625 is 5 to power of something, if not you just log it both sides. This one yesterday or lesson also I mentioned. Okay, there are two methods of it. Okay, so here they log it both sides. Okay, and then the log 5 move to the right hand side, then you get the N as 6. Okay. Okay, this is example 14. Now we come to example 15. Okay, you go through this example a while. Okay, this one is like the how do we say the direct sales okay, so they have a downline. Okay, so the one on the top we call it upline. Okay, then this AV of this will have a two downline. Okay, each member has to promote the company product by getting two downline. Okay, show the number of a member in each level follow geometry progression. So when they ask you to show, means you have to find the the R1, R2. Okay, make sure the R all are the same. Okay. So the number of member in each level can be written as this. Okay, so you try to write out a progression first. Okay, and then prove that the R are the same. Okay, they have a common ratio. So this is a geometry progressions. Okay, so here I think like this is not enough. You can show more lah. Okay, you can show the first one, the R1 is 2/1, which is 2, and then the R2 is third term divided by second term. So 4 divided by 2 is 2. And then show one more maybe R3. Okay, fourth term divided by the third term. So 8 divided by 4 is still 2. Therefore, you say since the R are the same, okay, so this is a common ratio. So this is an geometry progression. Okay, then we go to part B. If there are 9 levels in the marketing strategy, find the total number, okay, or member involved in promoting the product. Okay, 9 level, they want the total number of members. Means start from the first level, the one person, second level the 2 people, okay, until the 9 level. Don't know how many people okay, you add up all. So you are finding S9. Okay, finding S9. So just put in the formula, okay, S9 formula. Okay, make sure you know the A here is 1, okay, and then you know the R here is 2. Okay, just put in the formula. Okay, use the formula, the R minus 1, so that you have a positive at the denominator. So your answer is 511. Okay, we try to do this. Okay, by using Sn is this and Sn minus 1 is this. Okay, prove that Tn is equal to A R power n minus 1. Okay, how to prove this? Okay, we start from this left-hand side, Tn. Okay, we know that Tn is Sn minus Sn minus 1. Okay, because they give you the Sn and then they give you the Sn minus 1. Okay, so we try to apply this lah. Okay, so Sn, we copy the formula given. Okay, these are also, if you want, you can copy the solutions. Okay, minus, okay, Sn minus 1, same thing. Okay, we follow the formula given. Okay, now the problem is, okay, how we simplify it until we get this A R to power n minus 1. First of all, I can see the R minus 1, okay, both the denominator the same for both fractions. So I'm going to combine the fractions. Okay, same denominator, so our R minus 1. Then maybe what I can do is I expand, okay, bring in the A, okay, and then see what I can simplify. Okay, negative, be careful, this negative will bring the effect to these two. Okay, negative become positive, and then A. Okay, so next step will be this and this, okay, minus A and plus A. Okay, and then I have to try to factor out. Here I can factor out A R power n, maybe. Okay, so here is 1, and then the other terms, when I factor out A R power n, I have 1 over R, or the r power negative 1, okay, or 1 over r. Okay, if you cannot see how I get this, you can do it the other way around. Means this one times this, you get this. This one times this, you should get back this. Okay, so I continue. Okay, continue here. Okay, for this, 1 minus 1 over r. Okay, I try to find the common denominator, which is r. Okay, so the 1 is r over r, so it's r minus 1. Okay, and then over r minus 1 for this. Okay, and then the ar power n I put at the side. Okay, don't disturb me first. I want to try to settle this. Okay, and then this one, it will give me 1 over r. Okay, then ar power n. I'm very near to the answer already. Then this is r to power negative 1. So join back with this. So I have a ar n minus 1. Okay, so it's proven. Okay, this is how we prove the formula. Now is 8:24. Okay, so this is a homework for today. Okay, we try to finish out lah. Okay, so now we come to a sum to infinity. Okay, sum to infinity. The symbol is s infinity. Okay, that means the sum to infinity of geometric progressions. Okay, this one as I said just now. Okay, I show you the formula. So this formula is not given in the formula list. Okay, so this one you got to memorize. Okay, I will skip this. Okay, straight away we go to this. So you see, we're going to use the Sn formula, okay, and then adjust from there to get this S infinity formula, okay. So we start with the Sn equals to, okay, let's say we use this, okay, 1 minus n per n, 1 minus n, okay. Okay, for this, we don't use the other formula, which is r minus 1, because for the r minus 1, the r is bigger than 1. For s infinity to happen, is only for this case. Okay, the r must be smaller than 1. Okay, so the r is in between this. Okay, in negative 1 to 1. Okay, so we don't use another formula, the r minus 1 formula. We use this formula, 1 minus r formula. Okay, so now we see, okay, let's say the n become very, very, very big. Okay, so what happened to r to power of n? R to power of a very, very big number. Okay, remember the r is only take from this value. They don't take more than 1. If r take more than 1, it's different story already. Okay, let us see. I call out my calculator. Okay, wait for a while. Hey, are you still there? You're so quiet. Sometimes I'm out already, and then I'm talking to myself. Someone on the mic?
Yes, can.
Yes, can. Okay, thanks for your response. MS difficult, Okay, why we say here, this S infinity is cannot use for the R bigger than 1. Okay, I show you how. Okay, if let's say I just put 1.2, okay, power very, very big, okay, to the power of, let's say, I don't know whether can get answer or not. Ayo, math error, too big. Okay, again, 1.2. Okay, enough lah. Okay, you can see or not, the number is so big, okay, times 10 to the power 39, very, very big number. Okay, so the S infinity will not give you a value. Okay, if how about the R is smaller than 1, in between negative 1 to 1. Okay, let's say I put 0.8. Okay, power. Okay, hope can get a value. Oh, 0. Can you see? Okay, it's very close to 0 actually. Maybe I don't put power 5000. I put power 500. Okay, can see or not? The number is very small. So the power getting bigger, the number becomes smaller when the R is in between -1 to 1. Okay, you see the power is 10 to the power -49. Okay, so we come back here. Okay, if now the n is infinity, a very big number. Okay, so your R to power n will be very near to 0, closer to 0. Okay, when this is closer to 0, let's say it's 0 already. So 1 minus 0, so it's 1. 1 times A, so it's A. Therefore, this is how you get the formula. Okay, so this formula I want you to copy. Okay, and then you have to know this formula is from this Sn, is not from the other Sn formula. Okay, because of this. Okay. Okay, so remember, if the questions, okay, the R is not in between -1 to 1, okay, if the question asks you to find the S infinity, the question got something wrong, okay, cannot be. They cannot ask you to find S infinity. The S infinity is a very big number that we can't see the end, okay. But if the R is in between -1 to 1, yes, they will ask you to find the S infinity, because the S infinity is a very concentrate number already. Okay, means you will have an answer for it. Okay. Okay, and then for those like to have a very challenging mathematical concept, you can look at this. But I go through this already. This is quite complicated. They use the this sum of infinity, the S infinity of geometry progression, they prove the Pythagoras theorem. Okay, this is quite complicated. For those interesting on this type of maths, you can go through it. Okay, we come back to the example. Okay, find the S infinity for this 45, 9, and 1.8. When you see the progressions, that question that asks you to find S infinity, you will see the number, the progression is getting smaller one. This type of progression, yes, you can find S infinity. Like example, I give you example of experiment, the bouncing ball. Okay, when you bounce a ball, okay, the height of the ball will become smaller and smaller and smaller, okay, because due to the gravity. This type of a question, they will ask you to find the sum of infinity. Okay, another example, pendulums. Okay, you do the physics experiment, pendulums. Okay, the swing of the pendulums, it will become smaller and smaller. That type of question also they will ask you to find the sum to infinity. Okay, so now we see, very simple, we get the A, we get the R. Okay, A is the first term, 45. Okay, R is, okay, T2, 9. Okay, divide by the T1, 45. Okay, so you get 1/5. Now you see, the R should be in between -1 to 1. Okay, 1/5 is 0.2. Okay, so we continue with the S infinity. Okay, so use the formula A over 1 minus R, and then you get the answer. Okay. Okay, we look at this example. Okay, the sum to infinity of geometry progression is 31/1/2. So they give you the S infinity, okay, and the sum of first two term is 28. Okay, they don't give you the A, they don't give you the R, they don't give you the progression. They give you these two pieces of information. They ask you to find the common ratio, ask you to find the R. Okay, so this is the first equation you can get. Okay, just put in the S infinity formula, A over 1 minus R, okay, equals to this, and then you move the 1 minus R to this side, so your A is this. Okay, the other piece of information, sum of the first two terms is this. Please remember, okay, this. Don't go and use S2. I think this one will make you make a more complicated how to say, more complicated equations. Let me try. Okay, if you use the Sn formula as what? R minus 1, so 1 minus R. So A R N, sorry, and then 1 minus R. Okay, don't use the 1 R minus 1 because this one deal with sum to infinity. So we know that the R is in between the -1 to 1. Okay, so use this formula instead. Okay, so if you use this formula for S2, so your R2 R, and then this one equals to 28. Okay, it's more complicated though if you compare to you use this method. Okay, sum of first two terms, because two terms only okay, so the first one is A, the second one is AR. Finish the story. Okay, so remember for this type of question, don't use this. Don't use this. Instead of using this, because they only have two terms, okay, use this. Let's say they have a many terms, then we only decide, see, depend on the questions. Okay, so if you use this, then the whole thing will become more simple. Okay, you can just substitute the A as this. Okay, you factor out the A here. Okay, so become A and then in bracket 1 plus R. Then the A just substitute with this. Here they are using a divide. I still remember there is one questions during the physical class. We have one question something like this. I also asked you to divide the formula. Divide the both equations. Okay, but here this case you want to divide the both equation can. Another way is you just replace the A with this. Okay, either one. Okay, so after that you're going to get something like this. Okay, so you have the R, okay, is 1/3, and then also a -1/3. Remember, if R squared is equal to something, okay, your answer have to be two answer, okay, because R can take positive and negative. This one you have to remember. Okay, if you don't give two answers, means you short of one answer. Okay, then some of the questions when you give two answers already, maybe you got to reject one of it. That one you have to be careful. But for this case, there's no reason to reject any of this. So you for this case, you have both answer, okay, as your final answer. Okay, let us see this. Okay, this one. Okay, this one you can try by yourself. Okay, this one is how we make use of the sum of infinity. Okay, so you have a 1 plus a half plus 1/4 plus 1/8 plus until no end. Okay, means until infinite. Okay, so this is the that diagram that represent to this series. Okay, so you can see how they cut. Okay, they cut the half. This is 1, start with 1. Okay, then this is another 1 actually. Okay, so actually it end up with 2. The answer here is 2. Okay, so this another one, they cut it into half. So here is the half, which is the second term. Okay, and then the balance of half, another cut into half. So this is the 1/4, which is the third term. Okay, then the balance of it cut into half again. Okay, this is 1/8, which is the fourth term, and continue and continue and continue, smaller and smaller and smaller. Okay, so up to your imagination. Okay, then it will end up actually this is 1, this is another 1, so total is 2. This is how it get 2. Okay, so you can use a similar diagram and then prove this also. Okay, you start with 2 and then 1, and then this one actually will add up with 1. Okay, so 1, 2, 3, 4 altogether will be 4. Okay, this example is very it's quite fun. This diagram. Okay, you can let you imagine. Okay, now we come to this. Okay, if you still remember, okay, 0.563. Okay, on top of the 6 and 3, you have 2 dots. What's the meaning of these dots? Okay, you have learned it under the, I think the rational number. The dot on the top is a means you repeat the digit of 6, you repeat the digit of 3. Okay, so you have a 0.5, 6, 3, 6, 3, 6, 3, 6, 3. Okay, as these questions. Okay, if we see, we look at that, the previous method that we use to get fraction for this infinite decimal. This one. This is under chapter 4. Okay, I hope you still remember. Okay, this is the method we have. Okay, if this is a 6, 7 repeating, so we have to try to make the 6, 7, this whole set, okay, become the how to say, the integer. Okay, so how we make it? We will times 100. Okay, so you let this, the question be the n, okay, for the first equation. Then after that, you times 100 to both sides. Okay, therefore the left hand side will become 100n, right hand side will become 67.676767. This is your second equation. Okay, after that, okay, second equation minus the first equation. 100n minus n, you get 99n. Okay, 67.6767 minus 0.676767, you get 67. Now you got no decimal. Okay, so n equals to 67 over 99. Okay, the fraction that represent the 0.676767. Okay, now we're going to learn another methods. Okay, how to do this using the concept of a sum to infinity. Okay, so I go back to GP. Okay, look at these questions. Okay, let's say just now that questions we use at 0.67. Okay, so how we want to write it as a series, geometry series. Okay, so it will be 6, 7. Okay, the one repeat 0067. 0000067. Okay, and continue. Okay, so in this case, I put in bracket. I don't put continue with equal. Equal I'm going to put here, means I continue to do. I put in bracket so that I have the information for the A and the R. Okay, so A is 0.67 here. The R is second term divided by the first term. Okay, what's the answer? 0.01. Okay, so is your R in between -1 to 1? Yes. Okay, so you only can use your S infinity formula. So for S infinity, the formula is A over 1 minus R. Okay, so A here is 0.67. Okay, 1 minus R is 0.01. Okay. Okay, 1 minus 0.01 is 0.99. Okay, 0.67 over 0.99. Okay, move the decimal to the right 2 places. 1, 2, 1, 2. Okay, so 67 over 99. Okay, same as the answer just now. Okay, and then try and see 67 over 99 by using calculator. See whether can simplify somehow. No. Okay, so this is the final answer. Okay, so two methods. Okay, how to convert this infinite decimal to the fraction. Okay, now we have another example. Okay, 0.5636363. Okay, simplest form of fraction. Okay, so here same as what you have learned previously actually. Okay, the 5 is nothing to do with the 636363. So 5 are separate out. Okay, so 0.5, okay, plus, okay, the first term will be this. Separate out, okay? The 0.5 just put aside and then just copy, copy, and copy. Okay, so here you will have a sum to infinity series here. Okay, so here the same thing, this is the A, and then the R is the same thing, 0.01 for the R. Okay, 0.01. Okay, so you just put in inside this S infinity formula, this is the A, and then 1 minus 0.01. Okay, then 0.5 because you want to end with the fraction, so 0.5 change to fraction first. Okay, so here how they get this okay, let us see. Okay, this one is 0.063, then this one is 0.99. Okay, so what you can do is you want to get rid of the decimal so you can move the decimal to the right. Okay, here you need to move 3 times. Okay, here it move 3 times, then the denominator you move 3 times also. So 1, 2, 3. So you add one more 0. 1, 2, 3. So this one will end with 63/990. Okay. Then 63/990. You use a calculator. Okay. Simplify it. 63/990. Then you get 7/110. Okay. See 63/990. Okay, you get 7/110. Okay, and then press calculator for this. Okay, you will get answer 31/55. Okay, want to check answer? 31 divided by 55. Okay, 0.5, 63, 63, 63, 63. Okay, so your answer is correct. Okay, so this is another homework. Sorry okay, I don't want to drag some more because if I drag some more the next lesson only one question I'm going to show you the solve problem, no point okay, so one shot I finish in I finish this problem in this lesson. So we cross shop for this chapter, then next lesson we can go to next chapter. Okay, and then weekend. Okay, so I give you more homework Okay, let's see this. Okay, a company managed to sell 0.5 million smartphone in the year 2015. Every year, the sales of the smartphone increases by 4%. The sales increases by 4%. Okay, if 4%, the 4% you get it divide by 100 because of percent so you get 0.04. Okay, find the total number of smartphones sold from the year 2015 to the year 2020. Okay, total means 2015 add the number of smartphones sold at every year until the year 2020 means you are finding as annual this one. Okay, but how many years? Usually I will just use finger to count because the number is not so big so 2015, 16, 17, 18, 19, 20. So it's 8 lor. Okay, wrong 6 6 meh? 15, 16, 17, 18, 19, 20. Okay, sorry, 6 I don't know how to count. Okay, so your actually this question is asking for S6 okay. But the problem is where is the A? Okay, start with this 2015. So this is the A. This is the first term 0.5 million. Okay, don't go and change it. Million is a 60, the one. Okay, leave it in a million, and then your final answer also in million. Okay, so just leave it as 0.5. Okay, million in the first term. Okay, then what is the R? R you cannot set as a 0.04. Okay, you got to set as 1.04 because 1 is itself the principal. Okay, this is how much it increased. Okay, if you set your R as 0.04, your 0.04 you times with 0.5, that one is how much it increased, but it not plus itself. I hope you understand it. Okay, so you always you want to count example, how many after you increase by 4%, then you have to add with the original, okay, or we call it principal. Okay, this is why we don't do it here, but we add with the 1. The 1 is the itself, okay, the original or the principal. Okay, therefore the R here you got to take 1.04. Okay, you can take the R as 0.04. Okay, you can see by times with 0.5, you will see the effect. Okay, because it's increased. Okay, if you get 0.04 times 0.5, 0.04 times 0.5, okay, it's only 0.02. Okay, means the first year is 0.5 million, the second year is 0.2 million, cannot be long, because it says increase. Okay, so the second year, this number should be bigger than this one. Okay, but how about this? If you get 0.5 times 1.04, okay, then you have 0.52. 0.52. Now you can see the increase, okay, the increase by the 4%. Therefore, you must use 1.04. Okay, this type of questions are usually like, the interest, the how to say, the increased price of a house, okay, so you have to remember to plus 1 for the R. Okay. Okay, so the R here is a 1.04, the A here is 0.5, so you find S6 for the question A. Okay, now we go to question B. Okay, if 33% of the smartphones sold from the year 2017 to the year 2020 is a 5 inches phone and 14% is 6 inches phone. Okay, calculate the total number of 5 inches and 6 inches phone. What's the meaning? 5 inches, 6 inches. Okay, this is 33%, this is 14%. Okay, of the smartphones sold from the year 17 to 2020. Okay, 17 to 2020. Okay, means what? Okay, here you have a 15 to 2020. This is S6. Okay, 2015 to 2020. This is S6. Okay, now they only want to concentrate on 17 to 2020. Means they don't want 15, they don't want 16. These two take up. Okay, these two is the first term and the second term. Okay, if you want, you know your second terms already, you know your first term already. Just get the S6 minus these two. Okay, if not, you can find S2 if you want. Okay, so you just get 3.316. Okay, minus the first term 0.5, minus the second term 0.52. Okay, then you get the answer. Okay, this is the answer. Then after that, 5 inches one is 33%, 6 inches one is 14%. So you just add out these two. Okay, 33 plus 14, 47%. Okay, 47% of this 2.296 million. Okay, then is your answer. Okay, now, okay, you get the percent, okay, then add out the same thing, or you add out the percent first, only you get the percentage from the 2.296 million, also the same. Okay, so this is the answer. Okay, that's all for today. Sorry I browsed for so long. Okay, this is another homework for you. Okay, and then also this one. Okay, so altogether 4, 1, 2, 3, 4. 4 exercises for today. Okay, any question to ask before I end my lesson?